Hi to all. In this video, we'll be discussing about chapter 5, lesson 2, which is about bisectors of triangles. Now, in the previous video, we did learn about angle bisectors and about perpendicular bisectors. So, in this lesson, we'll be learning about bisectors of triangles as complete triangles. So, all of us know that triangle is called a triangle because it has three sides. Tri means three, and a triangle, so it has three angles, which basically means it has three sides. So since a triangle has three sides, it has three perpendicular bisectors. So when you construct a perpendicular bisector, you will find that they have an interesting property. So they have shown you just an example here, how to construct a bisector of a scalene acute triangle. So just if you want to try that out, you could do that. You can draw a triangle ABC and fold each line in half. Like for example, you want to find the perpendicular bisector of AC. So what you will do is you will fold A to C, that's half, exactly half. You will find a line which will pass through B. So that's the perpendicular bisector of AC. Now definitely this is not the perfect way of doing it. If you're perfectly constructing perpendicular bisectors of triangles, you definitely need to use the compass and the ruler. So, but here they're just giving you just a view of how it looks like, right? So the next one, similarly, you will fold for all the three sides. So if you would fold all the three sides, finally you will find that there's a point where all these three perpendicular bisectors meet. Okay, so what does this point mean? When three or more lines intersect at one point, the lines are said to be concurrent. So when there are three or more lines which are meeting at the same point, we call that point as a concurrent point. The point of concurrency is the point where they intersect. So no matter, like, you draw many lines, if you're drawing bisectors, you will find that all of these lines meet at one point. So this point is called the point of concurrency. So you saw that the three perpendicular bisectors of a triangle are concurrent. This point of concurrency is called the circumcenter of the triangle. So basically it's like the center of the triangle. So where all these three perpendicular bisectors meet in one point, that's called the circumcenter of the triangle. So easy words. What's circumcenter? The center of the triangle where all the three perpendicular bisectors meet. So what is the theorem regarding the circumcenter? It says that the circumcenter of a triangle is equidistant from the vertices of the triangle. So from the circumcenter, the distance to each vertex is equal. So if PA is equal to 6, PB is also equal to 6. Similarly, PC is also equal to 6. So easily you can remember from the circumcenter to the vertex. These are called the vertex of the triangle. The corners of the triangle are called the vertex. So from the center to the vertex, they all are going to be equal numbers, right? So the circumcenter can be inside the triangle, outside the triangle, or even on the triangle. Now circumcenter means the center of the triangle. Doesn't really need to be only inside. It depends on the kind of triangle we have drawn. So for an acute triangle, the circumcenter will be inside the triangle. For an obtuse triangle, it will be outside, and for a right triangle, it will be on the hypotenuse side of a right triangle. You will see later on why is it like that, but though we are not doing any constructions here, but you need to remember the circumcenters of three different triangles will be in three different places. So the circumcenter of ABC, that's the center of triangle ABC, is the center of its circumscribed circle. Now what is a circumscribed circle? A circle that contains all the vertices of the polygon is circumscribed about the polygon. Now this is a triangle. You can say this circle here is touching all the three vertices of the triangle. It's touching vertex B, it is touching vertex A, it is touching vertex C. So if a figure or a circle is touching all the vertex of a particular polygon or a figure, that's called as circumscribed about the polygon. All right, so let's see what this question has for you. Now using the theorem which we learned in the first slide, that's the circumcenter theorem, let's see how we can solve this question. KZ, that's segment KZ, LZ and MZ. So KZ, MZ and LZ. You can see they're talking about these lines are the perpendicular bisectors of triangle GHJ. So perpendicular bisectors already we have learned in the previous video. What is that? Perpendicular bisectors are the line is the line which divides the line in two equal parts. So KZ is the line which divides GH in two parts. Okay, so similarly ZL is the line which divides HJ in two parts. So if LJ is 9.5, JLH is also going to be 9.5. Same way, MZ is the line which divides GJ in two parts. So if MJ is 14.5, MG is also going to be 14.5. So the question here is find HZ. So they want you to find this length here, right here, this length. So to find out the length of HZ, we need to find which is the side corresponding to HZ. So how do you know how to find the length which is corresponding to HZ? You look at the other side of the line. So you can see that it's in the shape of a triangle. So if you say we have to find HZ, you have to find which is the other side of the triangle. That is this. So from the center to the vertex, which is the other length from the center to the vertex, there are three. One is this one is this, and the other one is this. So here we want to find this, which means the length of this is 19.9. So the length of HZ is also going to be 19.9. Basically, it's a triangle like that. So the distance from H to Z is 19.9. So this side is also going to be 19.9. So use the diagram above and find the length of GM. So you have to first figure out where is GM. So GM is here. This part is GM. So which is the corresponding part for GM? It is JM. So if JM is 14.5, GM is also going to be 14.5. Is according to the Circumcenter Theorem, because from the center, the perpendicular bisector, if there is one, the other sides become equal. Then GK. What is GK? Here, this part, right? So, okay, GK is here. Sorry for that. So this is GK. So we need to find out where is the corresponding part for GK. The corresponding part is KH or HK. So if HK is 18.6, so we could say here GK is equal to HK. So if HK is 16.6, GK is 18.6, GK is also going to be 18.6. Here GM is equal to JM. I forgot to write that. So better you write so that you will not get confused. The next one is the length of JZ. So J and Z, this part. They want you to find the length of this part. So which is the corresponding part for this? There are two, because like the whole triangle there are three. So JZ is one part. Which are the other two? ZH and ZG. So we need to find the length of any one. We already know ZH was HZ or ZH, it's the same, is 19.9, or even GZ was 19.9. I think we found this first. They have given already. GZ is 19.9. So you can say JZ is equal to GZ, which means it's going to be 19.9 as well. Even you could say JZ is equal to ZH. There's nothing wrong in that, because that's the circumcenter. So from the circumcenter to the vertex, any one vertex, the length is going to be equal. It's easy, only that you need to remember, you need to know how to read the figure, that's all. If you carefully observe the figure, it becomes easy. Now, the next part of this lesson was to find the circumcenter. Okay, now when you're finding the circumcenter, there are some kind of few steps you need to follow. So here they said find the circumcenter of triangle RSO with vertices. These are the given vertices. So always the first step is you must graph the triangle, because that will make the work 90% easier without graphing the triangle. So always graph the triangle. So accordingly, if you graph, you would find this red triangle. Now the next is find equations for two perpendicular bisectors. Now a triangle has three perpendicular bisectors, but you need to find the equation for any two. So to find any two, now according to this triangle, since two sides of the triangle lie along the x-axis and the y-axis, so you can see one side of the line is on the y-axis, one side of the line is on the x-axis, right? You have to find this to find the perpendicular bisectors of these two sides. So it's easy. What you need to do is just find out where is the center of this. So the distance from here to 0 to 3 is, okay, let me move this a bit. Okay, so the distance from, this is 0 and this is 4. So the distance from O to S is 4. Okay, now what is the midpoint of 4? That means half of 4, that's 2. So what you're going to do is you are going to draw a horizontal line along this y is equal to 2. Now you can see this is on y axis. So the half of y is going to be, half of 4 is going to be 2. So you will draw the line. Similarly, now you got the equation for one of the bisectors, that's y is equal to 2. The next one, you can see that it's along the x-axis. So the distance between 0 to 6, that's the distance from O to R is 6. And the half of 6 is going to be 3. So what you're going to do is you're going to draw a vertical line because this is a horizontal one. The side is horizontal, so you will draw a vertical line along x is equal to 3. So that you have found two equations now. So where is the point which they both meet? That's -3 and 2. So the circumcenter for the triangle is going to be -3 and 2. Well, when you do some more questions, you will definitely understand what you have to do. But for now, just remember, you have to find the center of this y-axis and draw a horizontal line. If the line is horizontal, you will draw a vertical line and find the equation, right? So let's get started with this practice workbook answers. But before that, I want to remind you, you just need to only do few questions from the practice workbook. That's only up till question number 6, because the remaining questions, we have not done any constructions. So those questions are not to be done by you, right? So getting started with this question, use the figure in exercises 1 and 2. SV, where is SV? This is SV, and TV, this one, and UV are perpendicular bisectors of the sides of triangle PQR. Find the length. So if these are perpendicular bisectors, you know what is to be done. You have to find the distance of RV. So where is RV? This one. So to find the distance of RV, now this is the circumcenter. So first check from the circumcenter to the vertex, because R is a vertex. So you need to find the distance from the circumcenter to the vertex. So you need to find another line which is equal to that, which means from the circumcenter to the vertex, from the circumcenter to the vertex. So we have two more lines. So you need to find which length of the line is given. Is the length for QB given? Because that's one of the circumcenter to the vertex. It's not given. So the one which is given is this one, VP, which is 26. So we could say here RV equals PV, which is equal to 26, which means the distance between RV is also going to be 26, which means the distance of VQ is also going to be 26, because it has three centers, perpendicular bisectors, right? Okay, the next one is TR. So they want you to find the length of TR. So that means half of the line. So which is the next half of the line? QT. So TR equals QT, which is equal to 24. It's a very easy one, but very careful observation is needed about the picture. Once you find out which side they have given the number and which angle are they talking about, it's easy to solve the question, right? The next question is find the circumcenter of the triangle with the given vertices. Now, as I did explain in slide number 3, slide number 2, I guess, right? No, 4. So you just needed to follow some steps. The first step is always graph the triangle. So first let's graph the triangle. So A is here, 0, 0. B is 0, 5. So 0, 5. This is B. And C is 5, 0. This is C. Now let me join all the lines. Okay, so this is the triangle we are going to have. All right, so we have ABC triangle, and we already drew the first one. Now, when I'm explaining, I did tell you that you need to find the equation for two perpendicular bisectors. Now, which one are we going to find the perpendicular bisector for? Because there are two sides which are along the y-axis and the x-axis. This is along the x-axis and this is along the y-axis. So to make it easier, we are going to find the center, that's the center middle of this one, that's A to C. Okay, so the distance from A to C is 5, right? A to C is 5. So what is going to be the half of it? So to find the equation of the line, we need to draw the perpendicular bisector. So what is perpendicular bisector? It divides the line in two parts. So to divide this line in equal two parts, we need to find the half of this. So half of this is going to be 2.5. So the perpendicular bisector is going to be a line which is half of 5. So let me draw the perpendicular bisector first. So this is 2, and so half is between 2 and 3. So let me draw the line here. It's going to be a vertical line. That's because this is y-x-axis. So if the line is on x-axis, the bisector is going to be a vertical one. So let me draw this 2.5. Okay, that was not a good one. Let me try that again, because it's quite difficult to draw with the keyboard. So let me just put my mouse on the right. So 2.5 is going to be somewhere here. Okay, so this is your first line, this is the first perpendicular bisector. So what is the equation for this line? So the equation for this line is going to be x is equal to 2.5. Okay, now you can see that it is a right triangle. So I already said before I started the lesson, the circumcenter of a right triangle is going to be on the hypotenuse side. So you need to know before you start where the circumcenter is going to be. This is a right triangle, so that's going to be on the hypotenuse. Right, now the bisector of A to C is already done. Now do the bisector for AB. So to do the bisector for AB, we definitely need to find the midpoint of AB. So what is the distance of A to B? A to B, the distance is again 5. So the bisector is going to be at 2.5, which means the half of 5, right? So let's draw again here. So this is 2, 3. So the this equation is going to be xy, not x, y equals 2.5. So where is the point where these two are meeting? That's at 2.5 and 2.5. So the circumcenter for this particular triangle is going to be at 2.5 and 2.5. X is 2.5 and y is 2.5. This is how you find the circumcenter of a given triangle. If it's a right triangle, it's a right triangle, it should be on the hypotenuse side. So again, I will repeat the steps very fast. The distance from A to C you will find, and then you will draw the bisector at the half of that distance. So then that will be a horizontal line if you're drawing for the x-axis. If you're drawing for the y-axis, it's going to be a horizontal line. So again, the distance from A to B was 5. So we have to do the bisector by half of that. So half of that is 2.5. So where that 2 meet is going to be the circumcenter. Now, if two bisectors are there, definitely the third bisector is also going to be there. So finally, your bisector, the circumcenter of your triangle will look something like this. Right, so let's try one more question. That's question number 4. So let me draw the triangle first. Always we have to start by drawing the triangle. So 0, 7. So this is D. This is D. And E is negative 3 and 1. Negative 3 and 1. That's here. E. F is 3 and 1. So 3 and 1. Yeah. Okay, so let me join the triangle first. Let me do it with thread so that we can differentiate lines. Okay, so this is our triangle. Now, as you can see, this is an acute triangle. So where does the circumcenter of an acute triangle be? Inside the triangle. Okay, now keep this in mind. So that means whenever you draw the triangle circumcenter, that should be inside your triangle. Right, so let's get started. Now to find the circumcenter, you have to definitely draw the bisector. Now you could do, there are 3 bisectors, you know, right? So you can find the bisector of anyone. You can find the bisector of E to D, or you can find the bisector of D to F, or you can find the bisector of E to F. Now, because EF is a straight line rather than these two slanted ones, so it's easy for us to find the bisector of EF. How are we going to find the bisector of EF? You can see how many units are there for EF here. The distance between EF is 6. How is it 6? Like 1, 2, 3, 4, 5, 6. So the distance of E to F is 6. So what is the half of 6? That's going to be 3. So I am going to draw, now you can see that the line, the side of the triangle is horizontal. So your bisector is going to be a vertical one. It's the opposite. If the line, the side is horizontal, okay, so the bisector is going to be a vertical one. If the side is a vertical one, then the bisector is going to be a horizontal one. Okay, so let me draw the bisector for EF now. So already I know it's at 3. So where is 3? 1, 2, 3. So my bisector for this particular line is going to be here. Let me choose another color so that we can differentiate it. Okay, it's going to be at 3 units, not 3 number. It's in 3 units because the triangle is not exactly at 0. It's half. So it should be like between, from here to here, it's 6 units. So the bisector is going to be at 3 units. So what's the equation for this line? The equation for this line is going to be, it's at 0, right? So x equals 0. Right. Now let's find the bisector for any other part. So you can do 2 things. You can find the bisector from E to DF or F to ED. So totally up to you. Now let me do it from E to DF. So I'm finding the bisector from E to DF. Okay. Now what's the next step we have to do? So you have to definitely find the midpoint from E to DF. So to find the midpoint, we are going to use the coordinates of D and F. That's because you're finding the midpoint from the bisector from E to DF. So we will be using the coordinates of the vertex D and F. So what's the formula for midpoint? X1 plus x2 divided by 2, y2 plus y1 plus y2 divided by 2 is the midpoint. Okay, so let me do that. So x1 is this, y1 is this, x2 is this, and y2 is this, right? So y1, x1 plus x2 divided by 2, and then y1 plus y2 divided by, divided by 2. Okay, so this is going to give us 0 plus 3 is 3. 3 divided by 2 is going to give us 1.5. And 7 plus 1 is 8, and divided by 2 is going to give us a 4. So the midpoint of DF is going to be at 1.5 and 4. So where is 1.5 and 4? It's going to be here. This is 1.5 and 4. Okay, now let's draw the line that's the perpendicular bisector and check where does that meet. So to meet, it definitely needs to be from E to, let me extend it a bit. All right, so where do you think are the two lines meeting now? You can see that there is a point where both the lines are meeting. Where are they both meeting? They both are meeting at this point right here, isn't it? This is the line for perpendicular bisector for EF from D, and there's the perpendicular bisector of E to DF. So where are they both meeting? They both are meeting at 0 and 3. So the circumcenter for this is going to be at 0 and 3. So let me quickly summarize what you need to do when you are finding the circumcenter of an acute triangle. Or what you need to do is first graph the triangle. Then you need to find the perpendicular bisector for any two sides. So definitely you can find, these are the three possibilities you could find. You could find the perpendicular bisector from D to EF. Okay, that's from point D to EF, the opposite side. Or you will find the perpendicular bisector from E to DF. Else you will find the perpendicular bisector from F to ED. So these are the three possibilities you could do. Okay, now you can choose any two. So first, the easy one, you go for the easy one. So if there is a horizontal line, that becomes easy for us because we don't need to do anything. We just need to draw a straight line along that. So to find the perpendicular bisector of EF, or what you need to do is see how many squares, how many units, and then divide that by 2 and draw a straight line where it is, where the center is. So the center of EF is going to be 3. So along this 3, that's 3, 3, it's going to be like that. If you divide something into half, it's going to have equal numbers. So 3, 3 percent. So that's going to be one equation, which is x is equal to 0. The next one, what you will do is, now this is done. D to EF is done. So the next is totally your choice. You can choose E to DF or F to ED. So I chose from E to DF. So you will take the coordinates of DF and then find the midpoint of both of them. So if you find the midpoint, you will get the coordinates as 1.5 and 4. So when you find 1.5 and 4, you just graph them. That's 1.5. It's 1.5 here and 4 here. So that's somewhere here. That means from here, you will draw a line to the point where you found the midpoint. So you will draw. So that means there will be a point where all these two lines meet. That line, that center becomes the circumcenter. To complete off your circumcenter, all what you need to do is just draw another line from F to touch these points. That's all. So this becomes the circumcenter. Well, practice makes it perfect. So you could try out some more questions to make yourself perfect in that. So this question here, use the figure. GJ and IJ are angle bisectors of GHI. Find each measure. So they want you to find the distance from J to GH. So that means basically they want you to find the distance from here to here. So how do you think you're going to find the distance from here to here? You have to definitely read the figure properly. You need to find out whether from the center, okay, did they give the distance for any other midpoint? So for example, say from J to JK, IK, did they give the distance from J to IH? No, they didn't. But they did give the distance from J to K, which is 64.3, which means the distance from J to GH is also going to be 64.3 because of the in center. From the center to the bisector, it's going to be the same distance. So from J to K, it's 64.4. 64.3. So from J to GH also it's going to be 64.3. Right. The next is the measure of angle JGK. Now where is angle JGK? JGK. So they are asking for this angle, this tiny angle here. So look at the figure. Is there any information which would give us that there is another equal angle for this? Simply you can say that they have marked this angle to be 23, which means this serves as an angle bisector because it has divided the angle in two parts. So which means JGK is also going to be 23 degrees. Now, one more thing before we wrap up, I want to explain just one more thing. There are two types of bisectors. One is the angle bisector and one is the perpendicular bisector, the line bisector, right? So if this was the triangle, that's a very big triangle. Let me draw the triangle this way. All right. So in a triangle, there are two things. That is an angle bisector also could be present. Also a line bisector, that's the perpendicular bisector, is also present. So how do you differentiate between a perpendicular bisector and an angle bisector? So for example, in the figure which I'm drawing, let's name this as ABC, the triangle ABC, and the midpoint, that's the circumcenter, is going to be, say, D. Okay. So if they ask you, DA, is this an angle bisector or a perpendicular bisector? So angle DA is going to be a angle bisector because this is angle A. So it has divided angle A in two parts. So DA is going to be an angle bisector. Okay, now how about the distance? How about DG? Is DG a perpendicular bisector or an angle bisector? DG is going to be a perpendicular bisector. How do you know that it is a perpendicular bisector? Because you can see it has divided the line in two parts, not the angle. So when it divides a line, it is called as a perpendicular bisector. And usually they are marked with these right angle symbols. If it is an angle they're talking about, so again, DB, is DB an angle bisector or a perpendicular bisector? You decide now. DB, is it an angle bisector or a perpendicular bisector? It is an angle bisector because it's talking about angle B. Angle B has been divided in two parts. So you can see that if it is marked with a right triangle mark, that's a perpendicular bisector. Else, even if it is dividing a line in two parts, that's an angle perpendicular bisector. If it's dividing an angle in two parts, that's called as an angle bisector. So hopefully you have understood this lesson. Yes, it is an easy lesson, but as I already said, it needs a bit of observation and practice. So till we meet again in the next video, keep practicing.